Hey guys, welcome back. Today we are going to solve a problem from binomial method from options SFM, and this specific problem deals with the risk neutral method which involves probability. Okay, and another method we are going to solve which is from delta binomial model using delta. This is the problem which has been also asked in the December 2025 paper problem also. Very easy problem only. We slowly solve the problem. Okay, when we have to find out the binomial method and risk neutral. Binomial is like a decision tree will come. It will be going like this. Okay, so using this diagram we'll be finding out the value of option. So what are the things in this we are going to do is we have to find the first thing when it comes to risk neutral is we have to find out the probability. First thing we have to do, and then we have to find the value of option under both cases, binomial method and risk neutral method. If they ask put the option also, they ask us to calculate now, we have to put the put call parity method. Using that equation we have to find out the put to value also, but in this question they haven't asked that. So next problem we'll see that, okay, in the delta problem. Now probability we have to find. What all the informations we have to give is the information pertaining to shares of Match On Limited is available below. Current market price 432, strike price 462. Okay, let's slowly build the picture for our reference. Okay, current market price which is 432, strike price which is rupees 462, 3 months duration option time, maximum price is 257. Always two numbers will only come in this binomial. Okay, to 537, and the minimum share price will be rupees 390. Interest rate 9%, and they have given the ERT also, which is 9% into 3 by 12, which is 1.0228 they have given. Okay, using this, the first thing we have to do is we have to find out the probability. So how can we find out the probability? We have to find the probability, we need the targeted future price. Targeted future price is equal to spot price today into ERT. What's the spot price? Which is 432 into ERT is 1.0228, which is 43 into 1.0228, which is rupees 441. Okay, 1 minute. Yeah, correct, 441.85. okay, now what we have to do with this value? The first thing we have to do is we have two values, which is max price, minimum price. What are those share prices? Which is 537, 390, right? 537, 390. What's the probability? Probability we don't know. Let it be x. 1 minus x is the minimum. Then multiply that, we'll get the product, which is 537x plus 390 minus 390x divisible, which gives a total of 441.85. That's why we found this value here. Okay, so 5 37x plus 390 minus 390x is equal to 441.85. 441.85 minus 390, which is 51.85. 537 minus 390, which is 147x. X is equal to 51.85 divisible by 147, which is 0.3527. This is our x. Let's find the 1 by 1 minus x, which is 0.647. Yes, we have found the probabilities of both the values. What's the maximum probability? 0.3527. What's the minimum probability? 0.647. Now let's get into the calculation of value of option, call option. How to calculate the value of call option? Same like how we'll be doing the net of structure. No, the same structure we have to put here. Max, min. What's the spot price? Spot price is $567 and 390. Spot price at 3 months. What's the strike price? Strike price is given in the question, which is 462 x 462. Okay, what's the action we have to take? This is the call option. I'll whether I will I buy 462 and sell at 567 x, I will exercise. Will I buy at 462 and sell at 390? It will be give us a loss, so lapse. So that's it. What's the gross payoff here? Gross payoff is 567 minus 462, which is 105. This is 537. Okay, we have put a wrong value here. So 537 minus 462, which is 75 is the gross payoff. Lapse, no payoff will be getting. Probability is 0.3527, 0.647. No value will come here. 75 into 3.3527, which is 26.45 is the expected payoff. Okay, now discount this with this is the future value. We need the present value of option. No, which is, what's the discount factor we have? 1.0228. $26.45 divisible by 1.0228. 26.45 divisible by 1.0228, which is 25.86 is the call option. We found the call option here using the risk neutral method. Now we'll find the same with the binomial model. Okay, what's the binomial model? At T0 spot price is rupees 432. If there is a high chance, if there is a higher value, then 537 will come and 390 in case of lower share price. Okay, what's the strike price we have? Our strike price is 462. What's the action? Same we are doing in a pictorial manner. Okay, 462. I will buy at 462 and sell at 367. This is exercised. I will buy at 462 and sell at, no, this is loss. So lapse. What's the payoff? Same, 75. So we have to do the value of option under binomial, value of call option under binomial, which is 75 into, what's the probability of max 0.3527 plus just we have been doing in a table, now we are doing in a formula. That's we can do in a table also, no issues. Divisible by discounting factor, which is 1.0028, right? Yes, 0022, 1.0228. We'll be getting the same value. That's it. This problem is over. We'll go to the next problem now. Oh, simple. First thing we have to find out the probability, and then we have to go to the value of call options under risk model and binomial model. Both the problems, both the area, the value of option will be same. Will come same only. The next model is deals with the delta model. Binomial with the delta. One minute. Delta formula is change in option price divisible by change in underlying asset. This option price, we can also put it as change in payoffs. Okay, now to find the delta, we have to find out the payoff. Max value, minimum value, as we already see. What's the share price at the max value? Share price at the max value is 600. Share price at the minimum value is 480. Okay, otherwise we'll use our regular method, which is spot price at third month max min, which is 600, 480. What's the strike price? Strike price is how much in this question? Presently, okay, we haven't read the question itself. Okay, 1 minute. Current market price, which is spot price today, which is rupees 540. Okay, max price 600, minimum price 480. Probabilities they have given. Okay, to find out expected values, and then call option on the shares that can be exercised only at the end of 3 months. Okay, at a price of strike price, they have given rupees 510 is the strike price. What's the risk free rate? 6%. Period 3 months. Okay, 6 into 3 by 12, which is 1.5% is the risk free rate for 3 months. Okay, what's the strike price we found? 510. Action. Will I purchase the share using call for 510 and sell at 60? Yes, I will do, because 90%, 90 rupees profit. Will I purchase at 510 and sell at 480? No, I won't do that. It will lapse. So what's the payoff here? Payoff is 90. Here we don't get any payoff. So what's the change in share price? Here the change in share price, which is rupees 120. Here what's the change in share price? sorry, change in payoffs, which is rupees 90. So 90 divisible by 120, 0.75 is the delta. Okay, we found the delta. Now what we have to do is to calculate the value of share option. No, so delta max price minimum. This share price is 600, 480. Delta is 0.75, 0.75. Multiply this 600 into 0.75, which is delta into share price, which is 450. Then 480 minus 0.75, which is 360. What's the payoff we have for maximum value, which is 90, right? And the minimum, there is no payoff. Deduct both these things. We'll get the result as 360, 360 matched. Always in delta, the max and minimum should be equal, and it is denoted that the portfolio is fully hedged. Okay, so 360 is the portfolio value. What's the present value of portfolio value? 360 divisible by 0.015, which is 0.1015 5113, which is rupees 354. Okay, what's the present value or value of shares today? Just what's the share value of share value today? Share value today is 540. Multiplied with delta, $405. Okay, delta is like the portion of the entire share price today. So we are only having 1.75. So we have removed the extra portion. So what's the difference? 354 minus 408, 360 divisible by 1.01, which is 464 minus 405, which is 50.36 is the value of call option. This is how we have to find out using delta method. Now we have found the value of call option. No, using this we can substitute with the put option, put to parity formula. Formula is stock price plus put is equal to call plus 1 into exercise price, PV into exercise price. What's the stock price today? Stock price today is 540. Put we don't know. Call we know, which is 50.36. Price of exercise price. What's the exercise price is 510. Divisible by discount rate, which is 1.015113. So 510 divisible by 1.015113 plus 50.36 minus 540, which is put is equal to value of put option 12.6 767 is the value of put option. Then comes the third one, which is expected value of option in the stock price at the end of 3 months. Expected value, max, min, 600, and then 480. What's the probability? 0.6, 0.4. More like sigma x, we don't know. Sorry. Probability of x, no, we do know in portfolio management, like that only it will come. So product, which is 600 into 0.6, which is 360, 480 into 0.4, which is 170, 480 into 0.4, which is 192. Total this will get the expected value of share price, which is 552 is the expected value of share price. What else they have asked? Expected value of option we have to know. This is at the 3 months end. Okay, what's the value of option? We have option in terms of payoff here. So payoff is maximum 90, and for minimum we don't have any payoff. Probability is same, 90 into 0.6, which is 54. So 54 is the expected value of call option, right? Okay, expected value of options we found. That's it. This is structure. The first thing if you have to do is step 1, calculate delta using the payoff, and then using that delta we have to find out the call option, and then we have to find out the put option using put parity, and then we have to find out the expected values. That's it. Thank you.